Okay, so here's number 5 from the book. I already started it once, and then my computer decided to do a Java update, and so I just canceled out and just restarted it instead of doing a new sheet of paper. So number 5 out of the book, you're trying to find the point where you're trying to find your inflection points and then classify concave up or concave down. Now I'm going to do this without graphing it. I'm not going to bother to graph it yet. We'll do it all from the calculus, and then we'll look at the graph in the graphing calculator here, and that'll make sure it just kind of verifies it. So in order to find your concavity, you have to find the second derivative. So first derivative of sine x minus cosine x is cosine x plus sine x, because the derivative of sine is cosine. The derivative of negative cosine is negative sine, but the negatives cancel to become plus sine. Then take the second derivative. Well, the derivative of cosine is negative sine, and the derivative of sine is positive cosine. So there's our second derivative. Now what I was saying before is to find the inflection point, you set it equal to 0. And then you move sine over to the other side, you get sine x equals cosine x. So there's two ways you can think about this. One is where sine and cosine equal at, because that's kind of what they're asking. Well, you got to remember sine is the y value, cosine is the x value. So if I draw my kind of cheap unit circle, I'm wanting to know when does the x value equal the y. Well, that happens in the first quadrant and in the third quadrant. And hopefully we could quickly realize, oh, that's the 45, 45, 90. So 45 degrees is pi over 4. And this guy is at 225 degrees because it's 90 or 180 plus 45. So that's going to be at 5 pi over 4 radians. So that's one way you can do it, is you can just use the unit circle and realize, okay, I've got, this situation. Now the other way you could realize this is by going back to here and dividing both sides by cosine x. That gives us sine x over cosine x, which is really tangent of x. And cosine divided by cosine is 1. So what I'm really asking myself is, let's see if I can kind of zoom in a little bit more to get a bigger picture. What I'm really asking myself is, when does tangent of x equal 1? Well, tangent of x equals 1 in the first quadrant. Opposite over adjacent is 1 over 1, so pi over 4. And the same thing in the third quadrant. So either way, my second derivative is equal to 0 between pi over 4 and 5 pi over 4. Now, it doesn't say it in here, but I'm just going to make this claim right now. We are at between 0 and 2 pi. The book does this business of realizing, okay, this is going to be pi over 4 plus 2 pi k, some 2 pi away, and then 5 pi over 4 plus 2 pi k. But I'm just going to say, you know what, let's just look between 0 and 2 pi so we can avoid that whole mess. So now, to determine our concavity, we have to do our line test for that. So it's between 0 and pi over 4, and then it's between pi over 4 and 5 pi over 4, and then I'm going to check between 5 pi over 4 and 2 pi. Now, to be honest, I'm going to cheat because it's late enough as it is. I don't have the energy to keep going with these much more. So I'm going to kind of cheat on this problem and go to the y equals and replace this with sine x minus cosine x. And then do y1 of something between 0 and pi over 4. So like 0.1. Actually, here's what you can really do, is do 0, just do like 0.1. Oh, sorry, dang it, I have to do it for the second derivative, don't I? Never mind. It wouldn't be y1, it would be y3. If I go back, remember I kept that third spot there as the second derivative. It's the derivative of the first derivative. So it'd be y3 of like 0.1. Which gives me positive 0.9. So I know I should be concave up between 0 and pi over 4. Now here's the tricky thing. You might know between pi over 4 and 5 pi over 4 there's like, well, there's pi in there. So you could do that. Or what you can do if you want to kind of get around that is, I'm doing pi over 4 and I want to do just a little bit more than it. What you can do is do second pi divided by 4 plus 0.1. That'll just go just to the right of pi over 4, and it'll take care of it. It can do that in the calculator. And we get negative then. And then when I want to do this, the last one then, I can do second, bring that up, second insert 5 pi over 4 plus 0.1. Again, I just want to know if it's positive, negative, positive. So this is concave down. This is concave up. Now, the way the book does this then, to summarize it, is they will say, okay, concave up, and then they give basically a break. So we're going to say from 0, sorry, we're not including the endpoints, 0 to pi over 4 and 5 pi over 4 comma 2 pi. And then a concave down between pi over 4 and 5 pi over 4. And then my inflection points are pi over 4 comma whatever that's going to be, which we'll do in a second, 5 pi over 4 comma whatever that's going to be. So let's see if those turn out to be nice numbers just by doing the y's. y1, and again y1's original function, so we'll do pi over 4. Oh, it's 0. Great. And let's see what 5 pi over 4 is. Oh, well, let's see what, yeah, let's see what that one is. Insert 5 pi over 4, also 0. Well, that was nice and easy. So that nice easy inflection points there. Now if I want to look at the graph, I need to change the window because it's that window from the old one. So I'm going to go from 0 to 2 pi, which is 6.28 and some change. X scale's 1. Actually, let's do x scale pi over 4, just so we can show where it is changing inflection at. Because it would be at pi over 4 and 5 pi over 4. Minimum, I don't know, negative 2, because this is a trig function. And actually, let's do like negative 5 to 5. I think this guy's going to move on us a little bit. So see pi over 4, it switches. 5 pi over 4, it switches. So those are the two places of concavity. Yeah, where the concavity changes.